In this video, we are going to be talking about linear equations. However, we're going to be talking about linear equations that have a slope of 0 or what we call an undefined slope. And whenever we have equations that have linear equations that have a slope of 0 or an undefined slope, you will notice that they only have one variable. So you'll either see a graph or an equation that looks like y equals some number or x equals some number. So with that being said, let's just dive into some first examples here. So in these following examples, you will notice that all of these are going to be set equal to x. And then to do these examples, we are going to first graph the equation, determine any x-intercepts, determine any y-intercepts that this equation has, and identify its slope. So looking at this first example, we have to graph the equation x equals 1. So I'm just going to draw out the xy plane. So this is our x-axis. This is our y-axis. We have to graph x equals 1. So before we graph this equation, actually, let's set up a table, an xy table. Now with this xy table, this is going to help us determine points that this line contains, so that way we can graph it. So let's start off with the value x equals -1. So we're going to plug in -1 for x, and whatever we get out, that's going to be our y value. So let's take a look. So I'm going to plug in x equals -1. So I'm going to plug in x equals -1. So we have -1 equals 1. Well, we're kind of stuck here, right? And also notice that -1 does not equal 1, right? They're not the same value. So this is a false statement. So x, the value of x being -1, that is not within this graph. So the x value of -1 does not exist at all in this graph. But let's try the x value of 1. So I'm going to plug in 1 wherever I see x. So, well, x is here. So I'm going to say, 1 equals 1. Well, in this case, this is true. 1 does equal 1, but we don't have a specific value for y or x in this case. So what does this mean when we are left with a true statement that 1 equals 1? Well, this actually goes back to Unit 6, if we recall, when we learned how to solve linear equations. Whenever we solve a linear equation, when we get a true statement like this tells us something special, or this is like a special solution, right? So what this means, when we get a statement like this means all real solutions, right? But what does all real solutions mean in terms of our y values? Well, that means our y values are infinite. So this sign here is an infinity sign. So this means infinity. So I'll write this out here, actually, off to the side, in case we need that. So infinity, oops, that does not look like an infinity symbol. And that also does not look like an infinity symbol. Yeah, I can't draw, that's why I'm not an art major. Anyways, this weird looking symbol here is an infinity symbol. right? So what this tells us is that y takes on all values. So this means that we can have the point, this means we can have the point 1 comma negative 100. That means that this equation, x equals 1, will pass through this point. You can also have the point 1 comma 2, because we can have an infinite value. Our y values are infinite, but our x values are only restricted to when x equals 1. So let's just do another point. 1 comma 5, right? So with that information, let's graph this. So we can start at 1 comma 2, because we know that that is a point. So we're going to go 1, 2. And then 1 comma 5, well, that's going to be up here. And then, well, 1 comma negative 100, that's very far off this graph. But what you might notice here is that this is just a vertical line. So that green line, the green line is the graph x equals 1. And now that we have graphed this equation, we have to also find the x-intercept and y-intercept and the slope. So let's see. Does this equation have an x-intercept? Well, remember, the x-intercept is at the point where it crosses through the x-axis. And this line crosses through the x-axis here, which that is at the point 1 comma 0. So the x-intercept is at the point 1 comma 0. And then our y-intercept, well, does this line at all ever cross through the y-axis? It does not. So this equation does not have an y-intercept. What about the slope? What do we think the slope will be? This one's a little bit of a special case. So remember, slope is rise over run, right? But this equation, it rises forever, and it does not run. It rises forever, but does not go right or left at all. So we can't get a tangible slope or a tangible value for the slope, because it goes on to infinity, forever down and forever up, without going left or right. So that means that this slope is undefined. So there you go. This is our answer, and this is our graph. Sorry, I did a lot of writing actually for this example. But I did all this just so we can start to learn how to graph equations that we haven't seen before, because you can actually use this method, this table, for any graph, even if it's like something you've never seen. You can plug in values, but that's more kind of like an algebra concept that I kind of just introduced. Anyways, let's look at the second example where we graph x equals negative 2. So I'm going to start off by drawing the xy plane. This is our x and the y-axis. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So we want to graph x equals negative 2. And before I graph this, I'm not going to write out everything like I did for the first example, but let's think about this before I graph it, right? So if we were to create a table like this, an XY table, and plug in the values, if we were to plug in the value x equals 5, Is that a true statement? Does 5 equal -2? It does not, right? But if we plugged, let's say if we plugged in -2 for the value of x, well, -2 does equal -2. So we get another case like this where we get all real solutions and y has an infinite number of values that it can take on. So we're going to end up getting a vertical line and x equals -2, just like we did with x equals 1, right? But in this case, x is going to be x equals 2 is a vertical line, but it's at the value of x equals -2 instead of +1, right? So that is our graph of -2, or x equals -2. So let's see, does this graph have any x-intercepts? It does at the point 2, 0. What about any y-intercepts? This graph does not have any y-intercepts. No y-intercepts. What about its slope? Well, just like as we've seen in example 1, the slope of this line, it rises forever and it doesn't go left or right, so we can't find any tangible value for this line. So this is also undefined. Okay. So for examples 3 and 4, I encourage you to pause the video and try these on your own before we work through it. And now let's work through it together. So graph x equals 4. We're going to start off by graphing the xy plane. And assuming you have given it a go, let's work through it. So as we've seen in examples 1 and 2, this is going to be a vertical line because we have x equal to some number or value. And specifically, the value is 4, so we're going to have a vertical line when x is equal to 4. So this is going to be our equation. And then our x-intercept, if you have not found the x-intercept, the y-intercept if there is one, and the slope, I encourage you to pause the video and try this on your own before I go through it. Now let's go through it together. So the x-intercept is right here at the point 4, 0. So that is our x-intercept. But our y-intercept, like we've seen with all the other graphs with x equal to some value, we don't have a y-intercept. And then for our slope, well, the slope is also undefined because there's no run. It's just a vertical line. We can't find a tangible value for our slope. Now looking at our last example, this one can be kind of confusing, a bit confusing at first for students who are learning these graphs. But it's the same exact process as we have been doing. So for this graph, right, we have x equals 0. So that means that this line here is going to be a vertical line where we have an infinite number of y values, but it's going to be when x equals 0. And x equals 0 here at the origin of the graph of the xy plane, right? So that means we're going to have infinite y values when x equals 0. So that means that we're going to have a vertical line right on the y-axis. So x equals 0, in other words, is directly on top of the y-axis. So this is the graph of x equals 0. So let's do some work. So our x-intercept, I encourage you to pause the video and think about this one actually, because it's a little bit different, just to see what you come up with. So our x-intercept, we do have one sort of at the origin, 0, 0. And then for our y-intercept, well, you might be like, the line's on top of the y-axis, right? But there's not a single point where this line intersects the y-axis. So that means that this line has infinite y-intercepts. So has infinite infinite y-intercepts. Okay. And then for our slope, well, just like as we always seen, it rises forever and there's no run, so the slope is undefined. Oh, and by the way, UND is an abbreviation for undefined. So looking at all these equations before I move on to the next type of equations that we're going to look at, what are some general takeaways that we can take away? Whenever we have a line or an equation that's x equal to some value, the graphs, number one, they're going to be vertical. They're going to be straight up and down. And the slope, what have we noticed? For every single one of these problems, the slope is undefined. And the x-intercepts are going to be at the value x is set equal to, right? And then for y-intercepts, you will never have any y-intercepts. And the only time that this case is broken where you have y-intercepts is with this graph. Every other time when you have x equal to some value, you're not going to have any y-intercepts. The only time that case is broken is when x is equal to 0 because it's directly on top of the y-axis. Okay. So moving on to our second type of graphs we're going to be looking at. We're going to have y equals some value rather than x equals some value. So all of our directions are the same. So we're going to start off by graphing the first problem. So we have y equals 3. So drawing the xy plane, x-axis, y-axis, 1, 2, 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So let's do this chart here real quick again. So let's plug in the value of x. Let's try to plug in the value of x equals 2. Okay. Plugging in the value of x equals 2. There's no x in this equation. So the value of x equals 2 does not exist. But so what does this mean? Because, right, if you think about it, we can try and plug in an infinite amount of x values, but we will never be able to find any information because there's no x. So what that's telling us is that this line here will never, ever touch this x-axis, right? But what we can find out is that we can look for trends, right? So looking at these examples, we know from these tables that we started with x, right? We plugged in our x values, but this worked out because we have x equal to some number. But here, this doesn't work out. So what if we switch this table? Instead of starting with our x values, we start with our y values and find out what our x values are. I'm actually going to draw this table over here. So let's start off with the y value equal to 2. Well, let's plug in 2 for y. Does y equal 2? Or does 2 equal 3? It does not. So this is out of the question. But what if we were to pick the value for y equals, or for 3? What if we were to plug in 3 for y? Well, in this case, it turns out that, well, 3 equals 3. That's what we'd get for the equation if we plug in 3. And just like we've seen in this here, we're going to go all real solutions. But instead of infinite values of y, we're going to get infinite values of x. So let's graph this. So we have y equals 3. This is when y equals 3 here at this point. And our x values are infinite. And our y values will always stay the same at 3. So we are going to have a line that looks like this. This is a horizontal line. So this is the graph y equals 3. So from that information, let's find our x-intercept, if we have any, our y-intercepts, if we have any, and our slope. Well, our x-intercept, do we have any? Is there a point where this line will ever cross the x-axis? The answer is no. So this line, or equation, does not have any y-intercepts. Or x-intercepts, I'm sorry. But this equation does have a y-intercept at the point 0, 3, which is right here. And then our slope, well, we're not rising by any value, but we are going left and right. So in this case, the slope is actually going to be different for whenever we have equations with y equal to some number versus x equals some number. We've seen that for x equals some number, the slope is undefined. But for this one, whenever we have y equals some number, our slope is going to be 0. So this is going to be our final answer for this question. Looking at example 2, I encourage you to pause the video and try this on your own. And assuming you have given it a go, let's work through it. So this is our x, y axis. We're graphing the equation y equals -2. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oops. So as we've seen before, if we were to plug in the value of y equals -2, we would get a true statement like this. And that would mean, right, we get all real solutions, which would mean we have infinite values for x when y equals 2. Or -2, my apologies. So that means when y equals -2, which is here, our x values are going to be infinite. And we're going to be left with this horizontal line. Right, so we get y equals -2. So let's find any y-intercepts, x-intercepts, y-intercepts, and our slope. So we don't have any x-intercepts. But we do have a y-intercept. And that y-intercept is going to be 0, -2. And then our slope, well, our slope is also going to be 0 for this one. Looking at examples 3 and 4, now that you get a general idea of what's happening, I encourage you to pause the video and try these problems on your own. And let's work through it. So, let's graph y = 0. X, Y, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Well, we know from our trends that we're gathering is that whenever we have an equation where we have y equal to some number, we're going to have a horizontal line, right? Because we have infinite values of x. But in this case, we're going to have infinite values of x when y is equal to 0. So when our y values on this y-axis, when y is equal to 0, which is at the origin, we're going to have infinite values of x. So that means we're going to infinitely go into our negative values of x and infinitely go to our positive values of y. So what that looks like as an equation is it's actually right on top of the x-axis. So this is the equation y equals 0. So now let's plug in, find some information. What about the x-intercept? Well, as we seen in this other example here, when we had x = 0, that's on top of the y-axis, it had an infinite number of y-intercepts. Well, this equation is also the same, except for it's on the x-axis, so it has an infinite x-intercepts. What about y-intercepts? Well, we can say that this equation has a y-intercept of 0, 0 at the origin. And then the slope, well, the slope is going to be the same, which is 0. And then for this last example, we have y equals 1/2. So remember, 1/2 is a value of 0.5. So this is 1, -1, y-axis, x-axis, 1, -1. So 1/2 is 0.5. So that means that our equation is going to be between +1 and 0 for our y values, which will go right through here. That's not quite there, or kind of like here-ish. Cannot draw for the life of me. Okay. So, finding our other information, do we have an x-intercept? Nope, we do not have any x-intercepts, so no x-intercepts. For y-intercepts, well, we do have one y-intercept, and that's at the point 0, 1/2. Or you can also say 0, 0.5 as well, whatever you prefer. Both are correct. And then for our slope, well, as we've seen, our slope is 0. So, quick takeaways for these problems, whenever we have an equation where we have y set equal to some value, our slope is always going to be 0, right? Slope 0, 0, 0. And we're not going to have any x-intercepts except for the only case of that time, or the only case that's not true, is when we have y equals 0, which we'll have an infinite amount of x-intercepts because it's directly on the x-axis. And then we will always have a y-intercept at the value that y is set equal to. Okay, so now that we worked with that, we're going to work backwards real quick just to make sure that we kind of got this idea down. So we're going to be given the slope and the intercepts of these equations, and we then have to say, okay, given the slope and this intercept, we have to come up with the equation. So looking at problem 1, if we have a slope of 0 and a y-intercept of, this should not say -2, 0. This should say 0, -2. So if we have a slope equal to 0 and a y-intercept of 0, -2, well, as we can see from our trends, whenever we have y equal to some number, we're going to have this horizontal line, which means we have a slope of 0. So the slope here, in this case, we're going to have y equal to some number. And remember, that number is going to always be set equal to whatever the y-intercept is, which is -2. So for this equation, we're going to have y equals -2. Looking at example 2, we have an undefined slope and an x-intercept at -2, 0. So I encourage you to pause the video and try this on your own. Let's work through it together. Well, if we recall, anytime we have an undefined slope, that is going to be a vertical line, which goes up and down like this, which is a graph of x equals some value. And that value is going to be where the x-intercept is, which is at -2. So x equals -2. Looking at example 3, we have a slope that's equal to 0 and a y-intercept at not 5, 0, 0, 5. So slope of 0, y equal to some value, and then we have a y-intercept of 5, so that's going to be y equals 5. Now looking at our last couple examples, slope of 0, y-intercept of 0. Well, our slope is 0, so that means we have a horizontal line that looks like this. So it's going to be y equals some value, and our y-intercept is at 0, 0. So we're going to have y equals 0. And for our last one, we have an undefined slope, which means vertical line. And when we have a vertical line, that's x equals some value. And our x-intercept is at 0, so we have x equals 0.